Welcome, stargazers. Could you imagine a cosmic event so massive that it casts shadows on Earth, visible even in broad daylight? That's the spectacle we might be on the brink of witnessing in the Orion constellation. The star Betelgeuse is behaving mysteriously, hinting at an imminent supernova explosion that could light up our sky like never before. But when will Betelgeuse go supernova, and what will it look like? According to scientists, what secrets could this celestial event reveal? Join us as we dive deep into the details of what's really happening with Betelgeuse and the impact it could have on Earth, and perhaps on the entire solar system. Located about 650 light-years from Earth in the Orion constellation, Betelgeuse isn't just any ordinary star. It's a red supergiant, one of the most luminous stars known to us, shining over 100,000 times brighter than our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not only for its brilliance, but also for its history and significance in human culture. Named after the Arabic phrase, Yad al-Jaza, which means the hand of Orion, Betelgeuse has been observed and documented by ancient civilizations for centuries. It has been a guide for travelers and a point of wonder for stargazers, with its reddish tint distinguishing it from other stars in the Orion constellation. Can you imagine a single star outshining our entire solar system? To give some perspective on the sheer enormity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star ever reach such massive proportions? At 10 million years old, it's much younger than our 5-billion-year-old Sun, but Betelgeuse's enormous size means it burns through its material much faster, leading to a shorter lifespan than other stars. Now, this cosmic behemoth, spanning a volume large enough to contain over 1 billion of our suns, is nearing the end of its life cycle. When stars of such size reach their twilight years, they don't just fade away. They go out with a spectacular flare, a supernova explosion that is beyond human comprehension in terms of its energy and brightness. Such an event has the potential to outshine an entire galaxy, casting bright shadows across vast cosmic distances. The last time Earth witnessed a supernova explosion this close was in 1604, long before the invention of modern telescopes. This event, known as the Kepler supernova, was the last supernova visible in our Milky Way galaxy with the naked eye. Remaining visible for over a year and a half, it was brighter than any other star in the night sky, and even remained visible during the day for weeks. What secrets do these celestial remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, documented the appearance of this new star. Intriguingly, remnants of this explosion, in the form of an expanding debris cloud, can still be observed today with modern telescopes, giving us insights into the violent ends of massive stars. Typically, supernovae have been rare spectacles on Earth. But imagine, for a moment, a stellar explosion so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event would electrify our atmosphere, potentially affecting satellite operations and possibly even the climate. Betelgeuse, with its unpredictable dimming patterns, suggests it could be gearing up for just such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Recently, stargazers have made a startling discovery. Between October 2019 and mid-2023, Betelgeuse underwent a remarkable change that drew the attention of astronomers and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had been consistent for years, began to decrease significantly. This sudden change was so obvious that even casual stargazers noticed it when comparing Betelgeuse to other stars in the Orion constellation. It implies that we are not just centuries away from seeing its supernova explosion, but perhaps mere decades, or even less. By April 2023, astronomical observations reported that Betelgeuse had returned to its usual brightness levels, leading many to believe that the period of anomaly had ended. In a surprising turn, the following months saw Betelgeuse's brightness increasing by a remarkable 50%. Such dramatic fluctuations, while typical of variable stars, were unusual for a star like Betelgeuse, which had predominantly displayed predictable brightness cycles. The sudden and extreme surge in its brightness thrust the star back into the spotlight, sparking discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most recognizable stars in our night sky, suddenly throw a celestial curveball? Stars are not just shining dots in our night sky. They are dynamic entities with life cycles, activities, and mysteries of their own. For many celestial bodies, periodic brightness variations can be expected, much like the rhythms of Earth seasons. Throughout its stellar lifetime, Betelgeuse has maintained a fairly consistent 400-day luminosity cycle. However, with the Great Dimming, it seemed to defy its established behavior, challenging our understanding of the celestial phenomena above. Now, you might be wondering, are we on the brink of a stellar revelation? While the exact reasons behind Betelgeuse's abnormalities are still under investigation, a compelling theory has emerged. This hypothesis, focusing on stellar activity and mass ejection, presents an intriguing scenario. Picture Betelgeuse as a colossal celestial volcano, subtly erupting and ejecting a massive amount of its matter into space. Past observations from the Hubble Space Telescope revealed that Betelgeuse had previously expelled a large quantity of its surface material into the cosmos. This ejection, a grand event, was 400 billion times the mass typically released during similar solar phenomena, equivalent to several times the mass of our moon. Such events can result in the formation of a thick dust cloud around the star, affecting its apparent brightness and temporarily making it more challenging to observe. Then, as this dust began to dissipate or was pushed away by the force of the star's radiation pressure, the shroud lifted. This could explain its subsequent return to regular brightness levels. Either way, these recent events suggest a star that is not finished astonishing us. Many wonder if we might be closer than ever to witnessing Betelgeuse's supernova explosion, an event that would be both a cosmic spectacle and a rare astronomical opportunity. Estimate that Betelgeuse may be moving toward the sundown of its life, a cosmic explosion occasioning a shocking eruption of energy that can eclipse a whole world immediately. This peculiarity happens when there is an unexpected change in the star's core. Such changes can emerge if a star ingests a lot of matter from an adjoining star or, in Bug's case, from the exhaustion of its nuclear fuel, which fountains its mass into the core, setting the stage for a destructive breakdown. Yet, what drives a huge star like Betelgeuse to its downfall? Born from the gravitational collapse of gas within atomic clouds, stars like Betelgeuse launch their journey by consuming hydrogen in their cores. This initial stage, known as the main sequence stage, lasts for millions of years and forms the foundation of a star's life. Yet, as stars run almost out of hydrogen, they evolve, embracing new energy sources. In the case of Betelgeuse, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium-burning stage is marked by the star's journey into a red giant. Over time, as helium reserves dwindle, the star undergoes further development and shifts into other burning stages, each characterized by the fusion of progressively heavier elements. The larger the star, the quicker these changes occur, given the immense gravitational pressures at play. Then comes the climax, when iron begins forming at the core. Unlike lighter elements, iron does not release energy when fused, so the energy produced isn't enough to counter the star's own crushing gravity. The star balloons in size and undergoes a collapse, followed by a huge rebound effect, resulting in the explosive force of a supernova. So, is Betelgeuse on the verge of a catastrophic end, or just biding its time? Ongoing research by Japan's Tohoku University suggests that the star may be in its carbon-burning stage right now. Lead specialist Haddock believes that the core could collapse decades after its carbon reserves deplete. Yet not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Betelgeuse is still in the earlier helium-burning stage. The one thing that scientists do agree on, despite these debates, is that Betelgeuse is slated to become the Milky Way's next supernova. However, Pinning down the timing of this event remains an endless guessing game, with predictions ranging from just a few decades to 100,000 years. Amidst these scientific debates and speculations about Betelgeuse's fate, one fact remains unchallenged: the very nature of our observations. When we look up at the bright sky, there's a subtle paradox we often overlook. This paradox is rooted in the very nature of time and light in our vast universe. Stars and celestial bodies are so distant that their light takes a great amount of time to reach our eyes. For instance, the speed of light, while being an astounding 186,282 miles per second, still has its limitations. Thus, the light from distant stars and galaxies takes its time to cross the expanse of space before it graces our sight. When observing Betelgeuse, you're actually seeing a display from 650 years in the past. To put that in context, when this very light set out on its journey toward Earth, the Renaissance was just unfolding, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a cosmic time capsule, granting us insights into its distant past. If, for argument's sake, Betelgeuse had already exploded in a glorious supernova, we'd remain unaware for another 650 years. So while we talk about and predict its imminent supernova, somewhere out in the vast universe, this grand event may have already unfolded. We're just waiting for it to navigate space-time until it reaches our eager telescopes. The recent discoveries around Betelgeuse have sparked intense debates in the astronomical community, with comparisons being drawn to another stunning revelation from earlier this year, SN 2023X. This recently observed supernova, occurring in a galaxy neighboring the Milky Way, reminded many of the fascinating dynamics and strange nature of the universe. SN 2023X was remarkable in its own right. Located a few million light-years away, it displayed a bright show of luminosity that quickly outshone its host galaxy. But what made it especially interesting to scientists and casual observers alike was its uncanny resemblance to what many predict will be the fate of Betelgeuse. The spectrum, intensity, and aftermath of the explosion offered a tantalizing glimpse into the processes that these massive stars undergo as they near the end of their life cycles. For some, SN 2023X served as a preview of what could happen if and when Betelgeuse meets its explosive fate. The sequence of events might resemble what was observed with SN 2023X. Additionally, the connection between these two celestial events underscores a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova like SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the obvious scientific implications, the explosion would have profound effects on human culture. The night sky, observed and revered for centuries, would change, leading to reflections on transience, the vast scales of cosmic time, and our place in the universe. Such monumental events remind us of the ephemerality of existence and our enduring quest to understand the extraordinary. As we contemplate the potential supernova of Betelgeuse, it's essential to grasp the broader implications of such an event on our cosmic neighborhood. When Betelgeuse finally reaches its explosive end, it could impact not just our immediate vicinity in the Milky Way, but also the dynamics of the interstellar medium. The shockwaves generated by the supernova will create vast regions of ionized gas, enriching the surrounding space with heavier elements forged during the star's life cycle. This process plays a crucial role in the cosmic cycle of matter, seeding new stars and planets with the essential elements for life. Moreover, the light from the impending explosion could serve as a stellar laboratory for astronomers. Observing the light curve and spectral features of the supernova could provide rare data on the life and death of massive stars. Every supernova offers a unique glimpse into the physical processes at play, revealing how energy is dispersed in such catastrophic events. By studying these phenomena, scientists can refine their models of stellar evolution, contributing to our understanding of the universe's life cycle. Aside from scientific advancements, a supernova can have cultural repercussions. Historically, significant cosmic events have impacted art, literature, and philosophy. The bright appearance of bug juice would likely inspire a new wave of creative expression and introspection. People across the globe would gaze at the night sky, pondering their place in the universe. This event could foster a renewed interest in astronomy and science, much like the curiosity that emerged during the Renaissance when celestial observations began to reshape our understanding of the universe. From a practical perspective, the effects of a supernova could extend to